Hi, welcome to Unit 2, Lesson 21, Graphing Linear Inequalities in Two Variables, Part 1. The learning objectives for today is when given a two-variable inequality and the graph of the related equation, you will be able to determine which side of the line the solutions to the inequality will fall, and then also to be able to describe the graph that represents the solutions to a linear inequality in two variables. Now, prior to this lesson, we had been working with inequalities in on a number line, so we were focusing on one variable. We talked about how to solve inequalities, we talked about compound inequalities, and then we talked about how to graph those inequalities. Now, though, we are moving into inequalities in two variables. So we are no longer using a number line, and we will instead be using an actual coordinate plane to graph. Let's take a look at our first question, which says, here's the expression 2x plus 3y. Decide if the values in each ordered pair, x, y, make the value of the expression less than, greater than, or equal to 12. So go ahead, pause the video, and try the first one on your own. All right, so the first one, all I'm going to do is I'm going to plug this in for x and y. So 2 times 0 plus 3 times 5. And this is going to be equal to 15. So that means my values will make this expression greater than 12. Okay, go ahead, pause the video, and try number 2. All right, I'm going to repeat the process. So 2 times 6 plus 3 times 0, and this is going to be 12. So for this one, I know it is equal to 12. Go ahead, pause the video, and try the next one on your own. All right, so 2 times -1 plus 3 times -1 is going to be equal to -2 plus -3, which is -5. So this is less than -12. Pause the video and go ahead and try the last one. All right, for this one, I'm going to do 2 times -5 plus 3 times 10. 2 times -5 is -10. -10 plus 30 is 20, so this is greater than 12. So if I were to turn this expression into an inequality, let's say 2x plus 3y is less than or equal to 12, my question is, which of these pairs, if any, would be considered solutions to this inequality? So we're looking for the solutions that when we added together, we are ending up with numbers less than or equal to 12. So in this case, the ones that would make this a true statement are 6, 0 and -1, -1. When we plug those in, it makes it a true statement, so those are solutions to the inequality. In the same token, so these were solutions, the other pairs were not solutions, right? So 0, 5 and -5, 10 would not be considered solutions to this inequality. Now, what I want to do is take a look at a graph that includes some points that are solutions and some points that are not solutions. So if you look at this graph here, notice that the points in the green are all solutions to this inequality, so they all make this inequality a true statement, whereas the points in the red are not solutions to the inequality. So when we plug them in, they make it a false statement. Now you may or may not be able to notice that there seems to be some kind of separation between the points that are solution and the points that are not solutions. Now, it's not 100% identifiable right now, but you could probably draw some kind of boundary line that separates the two sides. So I want you to keep that in mind for this next activity. All right, in this next activity, you are given 4 inequalities. What you need to do is study each inequality. You can choose 2 of your liking because we're not working in groups right now. Just choose any 2 you want. And go ahead and find some coordinate pairs that represent the solutions to an inequality and some coordinate pairs that do not represent. When you plot the points, I would use 2 different colors, maybe green and red, to help you identify. And then also make sure you plot enough points that you start to see the region that contains solutions and the region that does not. Make sure you're looking for patterns describing the region where the solutions are plotted. So I'm going to go ahead and fill these graphs in and show you what the pictures would look like. Yours should somewhat match mine. So go ahead, pause the video and work on that. So if we take a look, we can see this is what about your graph should look like. Now, in these graphs, notice that the x's are not solutions and the dots are solutions. And you can kind of see like an invisible boundary line on each of the graphs. Now, if we wanted to plot more points, if we wanted to see where another point falls that is not on this graph already, we could quickly tell by plotting that point and seeing which side of the graph it falls on. Does it fall in the blue dots or does it fall in the yellow x's? Now, when it comes to graphing linear inequalities, it really doesn't make sense to put an x or a dot on every single point that is a solution. So instead, we use shading to indicate where our solutions lie. So we shade the region that contains the points that are solutions. The hard part is right now, is the way it is, it's hard to tell where exactly the solution region stops and the non-solution region starts. So you want to think of what are some ways that we could figure that out without crossing into the gray area. So one idea is to use something called a boundary line to help us identify where the solutions start and where the solutions stop. Let's look closer at x is greater than or equal to y. So the solutions, if we were to write this as an equation, x equals y, we would say that the solutions are all the coordinate pairs where x and y are equal. And we can graph that line as it goes through -1, 1, -1, 0, 0, 1, 1, and 2, 2. So let me go ahead and graph that line. Okay. So this is our boundary line right here. You can see it goes through some of the points, right? 0, 0, 1, 1, 2, 2, so on and so on, and even backwards into the negatives. -1, -1, -2, -2, -3, -3, and so on. Now the solutions to this inequality, though, are going to be where all pairs of x equals y and where x is greater than y. So not only the points that fall on the line, but also the points where x is greater, which you can see falls below the line. And what we can do is, instead of drawing all of these points, we can just shade it in. By shading it in, you are indicating that all of these points are part of the solution to the inequality x is greater than or equal to y. All right, let's look at a different graph. Let's focus on 3x is less than 0. So again, you can see there is a segregation between the solid dots, which are solutions, and the x's, which are not. And there's an invisible boundary line that kind of separates them. Let's treat this as if it was 3x is equal to 0. What would my equation of my line be? Well, to solve this, I'm going to divide both sides by 3, and I see x is equal to 0. So that means my boundary line is going to be a vertical line through the y-axis, which is right here, right? But notice some of the points that are not solutions fall on this line. When we graphed the other inequality, when we drew the line, the solutions did fall on the line, and that was okay. But now there is issues with them not being solutions that fall on the line. So we have to have a way to indicate between whether or not these are solutions or not, right? And so we do that by using a different type of line. Just like in a number line, we use an open circle to indicate that that is not part of the solution, and a closed circle to indicate that it is part of the solution. We use a solid line when we want to say that the numbers that fall on the line are solutions, and for when we want to say that they are not solutions, we're actually going to use a dashed line. So that's going to look like this. Okay, so you can see here how I kind of dashed my line a little bit to make it indicate that the solutions, or the ordered pairs, I should say, that fall on this line are not considered solutions. So please keep that in mind for these two different types of lines. When the numbers that are on the line are solutions, the line is solid. When the pairs that are not solutions are on the line, then it is dashed. So let's go ahead and let's apply this to the next activity. All right, in this next activity, we're given an equation, x minus y equals 5, and then a graph of that equation. So they've already drawn the line for us. What they want us to do is sketch 4 quick graphs representing the solutions to each of these inequalities. Now notice the inequalities all have the same setup as the original equation. They all have x minus y, and they all have 5 on the other side. What's different is the type of inequality that is being used. So go ahead, pause the video, and attempt this on your own. All right, so let's go ahead and take a look at our first inequality, which is x minus y equals 5. Now, if you recall in the previous activity, we said that numbers or ordered pairs that are solutions should have a solid line, and ordered pairs that are not solutions should have a dashed line. So we need to keep that in mind as we are sketching our graph. The first thing I'm going to do is actually draw the line, since I know what that looks like. It'll look a little bit like that. Okay. And now what I'm going to do is figure out where my solutions fall. Do they fall above the line, or do they fall below the line? And to do this, I'm going to do something called a solution test. And I'm going to just pick any ordered pair in any section and see when I plug that in if I end up with a true statement or a false statement. My go-to is always to use the origin. And the reason for that is because the origin is 0, 0, and that's a quick and easy way to check, right? If I plug 0 in, 0 minus 0, I'm checking to see if that's less than 5. So 0 is less than 5, so this is a true statement. So this tells me here I need to shade towards the origin. So that means my shading is going to be above the line. Now before I actually shade, I still need to determine if I'm going to have a solid line or if I'm going to have a dashed line. So I am now going to choose an ordered pair that falls on the line, and let's just use 0, negative 5. So I'm going to use this point right here. When I do, I have 0 minus negative 5. I am checking to see if that is less than 5. 0 minus negative 5 is also 0 plus 5. So 5 is not less than 5. So I know that I'm going to need a dashed line. So let's go ahead and dash our line. dash, dash, dash. So now that I have my dashed line, I can go ahead and shade in the direction of the origin to indicate that is where my solutions will fall. All right, let's take a look at the next one. Okay, again, I'm going to have a line that goes through -5 and 5 like I did last time. Let's move that line down. Okay, again, I'm going to do a solution test to see which way I need to shade. So I'm going to use 0, 0 again. So 0 minus 0 is less than or equal to 5. And I see that it is indeed less than or equal to 5. So again, I'm going to shade towards the origin. And then I need to determine if I have a solid or a dashed line. So this time I'm going to use positive 5, 0 as my solution test. So 5 minus 0, is that less than or equal to 5? And I see that yes, indeed, it is less than or equal to 5. So that means the numbers on my line will be solution. So I can leave that as solid. And then I'm just going to shade towards the origin. Okay, let's take a look at the next one. So again, draw my line. Okay, do a solution test. I'm going to use origin, 0, 0. But in this case, it is not greater than 5, so that means I need to shade away from the origin. And by now, hopefully you've seen the connection that when it's a greater than sign or a less than sign, we're actually going to use a dashed line, just like we would use an open circle on a number line. So it's the same idea. So we're going to go ahead and make this dashed. And then go ahead and shade away from the origin. Okay, then last but not least, again, draw my line. Okay, you can probably guess we're going to shade away from the origin, but let's check that. 0 minus 0 is greater than or equal to 5. Again, not true, so I need to shade away from the origin. Again, because this is a greater than or equal to sign, I would use a solid line. So I'm going to shade below with a solid line. All right, so let's go ahead and take a look at the next page, which is a continuation of this activity. Now, for this page, or for this part of the activity, it's already giving us the graphs, and we need to decide what the inequality is. So let's go ahead, pause the video and try this on your own. So let's take a look at graph A. Notice it is a horizontal line that goes through positive 3. So if I was writing an equation for this, I would use x equals 3. But I don't need an equation, right? I need an inequality. But I'm still going to use the x and the 3 to write my inequality. I just need to decide what my symbol is. The first thing I notice is that is a dashed line. So that tells me I'm going to either have a greater than sign or a less than sign. The other thing I notice is that everything is shaded to the right of 3. So that means I'm looking at all the numbers on the x-axis that are bigger than 3. So that means my inequality is going to be x is greater than 3. For B, I notice I have a horizontal line, and if I was writing an equation for this, I would write it as y equals -2. But again, we needed an inequality, but I can still keep the y and the -2. This time, it's a solid line, so regardless if it's going to be greater than or less than, I know it's going to be or equal to. And I also noticed that it's shaded below the -2. So that means I need all the y values that are less than -2. So my inequality should be y is less than or equal to -2. Let's look at C. For C, I have a diagonal line that goes through the origin. I notice that it goes up 2 and over 2. So if I was to write an equation for this, I would write it as y equals x. But again, we don't have an equation, we need an inequality, but I can keep that y and x. I notice also that it is a dashed line, so I know it's going to be either less than or greater than. So if I look at my ordered pairs, the area that is shaded shows the y values being bigger than the x values, right? On the y-axis, we have 2, 4, 6, and 8. On the x-axis, we have -2, -4, -6, -8. So that tells me in any ordered pair in the shaded region, y is always going to be greater than x. Okay, last one. Again, I'm going to use the y and the x. This time I notice it's a solid line, so it's going to be or equal to. And then in the shaded region, this time, my x values are bigger than my y values. So my inequality would be y is less than or equal to x. So some big ideas as key takeaways from this lesson is that be careful with, once you know what the boundary line is, how to decide which side of the graph to shade on. Some people will mistakenly say that just because you have a less than symbol, that means you should shade below the boundary line, and if you have a greater than symbol, you should shade above the boundary line. But that's not always the case. So be very careful. You cannot assume that symbols like less than or equal to means to shade below. It's important that you do a solution test on either side of the line to determine which pair of values make the inequality true, or to reason carefully about the inequality statement and think about pairs of values that would satisfy the inequality. So don't just assume, always test your solutions. So go ahead and to wrap up, you're going to complete, grade, and correct the cool down for this lesson, and then also repeat that for the practice worksheet. Thanks for watching.